Thank you. Hi all. Today we'll speak a bit about Android iBeacon, beacon emitters, beacon detection, and I will show a little demo in the end. So, first about me, I'm from Google Developers Group Dnipropetrovsk, that is in Ukraine. Also, I work as a software developer in Ukraine for 3 years, and from recent time, I also lead in Women Tech Makers Ukraine communities in different cities. So, what is beacons and what is iBeacon? Actually, iBeacon is a specification provided by Apple, and beacon it's like little devices that work on Bluetooth Low Energy. This Bluetooth Low Energy chip and can emit some signals, and how they looks like. And as you see on the picture, the same. And a bit about structure of these devices. They are based on Bluetooth Low Energy, as I said, and among Bluetooth Low Energy, they also contains system on chip. They have a microprocessor and small battery. And BLE technology was created and announced firstly in 2009, and then iBeacon protocol and standard were shown by Apple in a WWDC conference 2 years ago. So in iPhone, Bluetooth Low Energy supported from 4S model, and in Android, Bluetooth Low Energy supported starting from Android 4.3. So this is internal structure. As you can see, there is a little chip and battery, and this battery can be useful for 1 or 2 years. It depends on beacon, it depends on vendor, and it depends on mode of scanning. So quite simple. And what is typical beacon usage? From maybe recent year, beacon became popular because they can provide such services like indoor navigation, detection, some device-ment, advertisement, and typically they works as in triangulation mode. So beacon just emits the ID and small amount of data, then telephone scans this data and then send it to the cloud, where when receives some more information about this beacon and more detailed information that related to this beacon. And then application can parse this data and interact with user and show more like a sales, discount, more information on the location, and so on. So what is BLE? As I said, this is Bluetooth Low Energy, and this is a new technology, new standard that is aimed to reduce the power that is used for Bluetooth detection, using Bluetooth devices and all wearables devices using Bluetooth Low Energy, because versus standard version it requires more power, and wearable devices can be much more time useful, can be much more time not require charging, and so on. And modern, not just wearables, another healthcare devices, entertainment, some entertainment stuff are also based on Bluetooth Low Energy. So let's compare Bluetooth Low Energy and usual Bluetooth old version. They have non-compatible protocols. So to detect Bluetooth Low Energy devices and parse the data, it uses new protocol, and if device detect phone or another device detect Bluetooth devices, then it's not equal that this device will be detect Bluetooth Low Energy devices. But that use the same frequencies, almost the same speed, and as I said, all embedded devices, as maybe you have seen the updates from Google I/O that now become popular Internet of Things, and Internet of Things will be also based on Bluetooth Low Energy technology, because it also need to consume less power on maintaining, less power on maybe on just usage. And let's compare technical characteristics. The range of action of Bellier devices are a bit bigger, but unfortunately they are not speed up that regular Bluetooth devices. Also, the new feature that Bluetooth Low Energy can support different and not limited simultaneous integration. But in usual Bluetooth, we supported just not bigger than 7 simultaneous services and interactions. And as you can see, the minimum total time to send data is significantly less. It's only 3 milliseconds versus classical Bluetooth technology. And also less is power consumption. So if you compare it in range from 20 to 100 times less, so these devices can work for years. And now let's go to the technical details. So Bluetooth Low Energy, and based on GATT, it's a generic attribute profile. This is a specification for interaction with Bluetooth devices. And there is some typical instances that are used with GATT. It's a client, so devices are divided to the client as a server. So client initiates GATT commands and detects scan the Bluetooth Low Energy devices. Server emits a signal and sends the data. And the data is a set of characteristics that are that contain a value and a descriptor that contains human-readable description of the characteristics. So, and if some devices, for example, heartbeat rate, devices can contain several characteristics. So a set of characteristics are contained in a service. Sorry. Service is a set of characteristics for Bluetooth Low Energy devices. And the base GATT operations contain discover and services, filtering the services by UUID, find secondary services for our service, and also matching the service gives selected UID. Also from For the service, we can read all characteristics and parse them. And for emitting the signal, Beacon uses called advertisement data. So each time Beacon emits the scan response data, and this data is up to 31 bytes. And this data divided to the structures, and now let's see what the structures are. So the first one is basic structure. It contains a little bit information. So always the first bytes indicates the remaining bytes. So for advertisement data structure 1, we have first byte equal to, it's like 2 bytes remained. The second byte identifies the advertisement data type, and the next one indicates some sentence, some flags that contains 5 flags, and each flag is tagged with 1 or 0, and all these 5 bytes, 5 bits are indicated and shown as a byte in advertisement structure 1. So, what contains advertisement structure 2? It's maybe the most interesting and useful part of the advertisement data, because they contain manufacturer specific. It's like data type. Also contains vendor ID. For example, some beacons have manufactured by Google, and the value 224 indicates that this beacon are issued by Google. So if we have some shopping malls with several companies, different beacons, different vendors, we can unify and distinguish our beacons, and then parse the data just from these beacons. And for manufacturer ID, we can set up values up to 2 bytes, and maybe for future will be much more range, because by now not just many companies, not just huge amount of companies produce beacons. And also after this part there is a beacon prefix. It's more specific values and information about the beacon. For example, alt beacons contain these two values equal BE and AC. So when you create a filter for scanning the devices, you can create a filter with beacon prefixes that equals these values, and you will scan only devices that are ILT beacons. The next part contains UID. It's like unique identifier for the beacons. And also we have two structure, major and minor, that are about 2 bytes. And this structure also can be used for personal purposes. For example, if you have a shopping center and several floors, you can set up major data as that equals the floor number, and minor data that equals room number. And the last byte is TX power. It's a instance of beacon signal. So TX power value is like a ideal value when a device is located in 1 meter far from the scanning device. And in general, you can see how looks the data. So the first 9 bytes are beacon prefixes that containing information about vendors, about beacon specific information, about data specification. Then there is proximity UID that can help with distinguishing the beacon's minor and major parts that can be helpful for some detection purposes. And TX power that we will use for detecting the signal from the beacon and analyzing what is the instance of this signal. And let's see how Android supports BLE. So BLE support was added with Android 4.3, and also were added like a central and peripheral roles. So if device can emit the signal, this device is peripheral, and central devices scan for BLE devices and can analyze and parse the data. Also, as I mentioned, there is GATT server and GATT client. So if device receives and analyzes something, this is client, and if device publishes something, this is a GATT server. And also with Android 4.3 were added Bluetooth users feature Bluetooth LE. So you can specify if you want make it required. So if a device don't have a BLE support, your application have no ability to be installed on the device. And if the action required is false and your application use BLE, you should manually check if the device supports BLE, and if no, you need to disable and say that you are disabling BLE support and BLE features. Also, to interact with BLE, you should add the permissions in Android manifest. The first permission, Bluetooth, are required for established connection, interact with device, and so on. And the second, Bluetooth admin, are required if you want to change some settings. So in more common cases, you need to define both these permissions. And as I said, to check the hardware, you need to, you need to add feature Bluetooth LE. Sorry again. Okay, let's go. To interact with Bluetooth, you need to create the Bluetooth manager and instance, and this can be done by using system service. So you can see it on point 3, and then get the Bluetooth adapter instance. In other actions, you need to check if the Bluetooth is enabled, and if no, you need to enable it manually and show the activity for results that was used, and identify and show users that we need to enable Bluetooth. To start BLE scanning, before the start BLE scanning, you need to define the LE scan callback, and then you can just use start LE scan. This is for Android 4.3, and we should note that in Android 5 there is were created new API that are much more useful, and now you can filter the scanning. You can select some UIDs, some other properties, and scan not all devices, scan only devices with selector filters. Also, scanning is implemented in background red, and this is also enables to reduce power consumption. And also we can scan devices in several modes. It's low power, so you scan less frequently, but power is saved much more. And there is low latency mode when you scan with minimal interval and detect the devices more frequently. And in table there is a comparison between how this affects the battery. So okay.
Is for connection? Okay. Sorry.
Okay, you can see on the table the comparison between these two modes. So in low power duration, we can save battery almost in 2 times, and there is absolute values. So maybe if you need to scan devices like in background or not very frequently, this mode is much more useful. And you can see the typical time between detections. So in low power it's 4.4 seconds, and low latency is 100 milliseconds. And based on this and on your purposes, you should select the mode. To scan, before scanning the devices, you should set the filter and set the settings. Filter are set using mask, so we just put in one buffer the values that are expected that we want to scan, and in the mask buffer we should put just 1 or 0. So if you want to this byte should be scanned, we should put the 1, and if no, we should put the 0. And then we are adding the settings. So at first this is a scan mode and the report delay. And after that we should set up scan callback, and then we can scan devices with start scan function. So this is maybe all for scanning devices. It's pretty useful and pretty simple. And the second part is for emitting Android devices. So your phone should also be emitted as beacon. And in Android, this feature is supported just for Nexus 6 and Nexus 9 devices, and works from Android 5.0. So in order to create a beacon emitter, you need to define the Bluetooth LE advertiser data and settings. So also you should set the level of transmission power. It's like if it has several states, it's like near, intermediate, or far, and or known. So in order to set advertised data, you should do maybe the same procedure as for creating a mask for filter. It looks pretty the same. And then set settings. It's our scanning mode and our TX power mode. So for this piece of code, we set the medium signal, and if other device is scanning our beacon, it will be indicated as medium, so not far, not near. And for start emitting the signal, you just need to call as start advertising and pass all these parameters. And also, I will show a demo of the project that we are currently working on. This is oriented for shopping malls, so and for wearables. So if you need to show some more details when users are going across your shop, you just need to set up some beacons nearby and let users install your application. Then when the user will be going across your shop, there is a button that will be shown on the wearable screen and will pulse up. And then if user tap on this button, it will see some discounts, some sales. And then, if it's not interesting for him, it can be swiped right and dismissed. Or if it is interesting, a user can tap and see the barcode and go to the shop, scan this barcode, and receive the discount. And how this looks on real devices. And also, I will show a demo how it looks on emulator. Okay. Okay. So. Okay. No. Okay, thank you. So as you can see, there is like a pulsar button, and user can drag in, and also there is it's like not a banners, like not full screen advertisement. It's not annoying, and if necessary, you tap on this and swipe if not interesting. And this maybe looks not annoying as usual banners. And if user don't tap it and don't want to receive the updates, when user will be going outside the shop, this button will be automatically disabled. So. Thank you. Let's describe the typical user cases when the beacons will be used. So the first is for runners, and to remove cheating, we can add the beacons devices on during the road, across the road. So when runner is going across this device, it will be automatically checked, as I said, in shopping malls for some showing some discounts, sales, and so on. For indoor navigation at the conferences, at the some big areas, or for example shops, so it will be provided some interactive map for the users. For museums, so if users are going to the some exponats, the audio guide can be automatically switched in the suitable thread. Also, it will be maybe useful for clinics when you go to the interested doctor and interested cabinet. You could check some information, reviews, time of work, working hours, and all necessary information if needed. Also, it can be used in hotels for check-in and check-out, and apps for disabled people. So for disabled people, it will also add audio guide, how it can be something like navigation or other hints. And for device location inside office, it was invented by our team. It's like indicating test devices inside the office. So you just need not to ask anyone. You can check the device location in the application. And that's all. So maybe time for questions and answers.
Yes, first, thank you very much, Kseniia, for the presentation.